All right, this video is providing the solutions for the winter break assignment. This is super important, guys, that you have these problems fully down and ready to move on past these topics before our first class. So our first class will start at 1:45 on Monday, January 4th, and 15 minutes prior to that, this needs to be turned in, and that's to require you guys to make sure that you have reviewed the topics that are going to be really essential for this unit. Okay, so remember, when we're finding an integral, you're doing an antiderivative. And if for some reason you missed that lesson or you need a reminder, there is a video that you can watch that will go through those basic integration rules. So in general, though, I'm going to use the power rule if it's a polynomial. So I'll add 1 to the power and then divide by the new power. I'll simplify that in a minute. And then for each term, I will continue that process, add 1 to the power, divide by the new power. And then if it's a constant, we multiply it by x, and then there is a plus c, capital C, as a constant at the end, because when you take the derivative of this expression, it needs to get you back to what you were taking the integral of. And so that plus c is there because you could take a derivative of any constant and it would zero out. So we are representing that there is some constant, even if the constant 0, at the end of this expression. Number 2, I'm again going to use the power rule. I'll add 1 to the power, and then I'll divide by that power, that new power. So this would become a 15 on the denominator. It was previously just a 3. 3 times 5 is 15. Add 1 to the power, divide by the new power, and then if there is a constant, we need to multiply it by x. That would correctly give you a derivative back of -4, and then plus c. This one did not have any further simplification involved. Number 3. Well, remember, we're not taking a derivative, we're doing the antiderivative. So when we say the derivative of sine in here, the derivative of sine is not what we're asking for. We're saying what function had a derivative that would get you sine. Well, the derivative of cosine is negative sine. We have the negative here and the sine. The 3 is just a constant multiplier. So this is 3 cosine of x. And then what function has a derivative that's cosine? Well, that would be sine. So plus 5 sine of x. And then all indefinite integrals have a plus c at the end. Number 4, what function has a derivative of secant x tangent x? That's secant x with a multiplier of 4, and then minus 11x plus c. Last one, what function has a derivative of cosecant squared of x? Well, the derivative of cotangent is negative cosecant squared of x. I already have a negative here, so this would be 2 times the cotangent of x plus c. All right, for these next parts, we're going to use a diagram that I spaced this out, by the way, compared to your picture, just so I'd have room to show you the solutions. So we do need to add in some areas. Region A is 4, region B is 3, region C is 13. If you miss the lesson with the accumulation of areas, you will want to watch these 2 videos in here. Now keep in mind that if an area is written below the x-axis, even though this says the area is 4, we would record this as an area of -4 for A. I did not leave myself room. That's awesome. That has an area of -4. B has an area of 3. That's above the x-axis, so we'll keep that as a +3. C has an area, it says 13, but it's really -13 because we are below the x-axis. And so the definite integrals, we'll have those starting and ending points, and that will allow us to see where the vertices or where the area starts and end. So if I want from -3 to 2, we read this from left to right. Okay, areas traditionally are done from left to right. The bottom number is on the left to the right. If we have it in a different order, we are going to need to think about that just a bit differently. All right, so from -3 to 2, well, that area is just the area of region A, which we described as 4, but because it's below the x-axis, we list as -4. From -2 to 1 actually combines more than one region. -2 to +1 is going to combine that green region and this pink region together. And so when we combine those together, that would be 3 plus -13, the 13 being negative because that area is below the x-axis, which would be -10. I'm going to have to pause this video really quickly and answer the phone. I'm going to actually I don't know how to pause it, so I'm just going to go ahead and keep going, and I'll call them back. All right, for number 8, the integral from -3 to 1 of f of x. So from -3, now I'm combining the yellow, the green, and the pink. So the yellow was a -4 plus the green. I'm just accumulating plus the pink. And so I would end up with -14. Let's see if I can do that right. Number 9, I'm going from -1, or from -3 to -1. So I'm combining the yellow and the green, which is an accumulation of -1. Number 10, I'm going from -2 to 3. Now this is interesting. From -2 to -3 is backwards. We are going to view areas as going from the left to the right, and we're accumulating as we go from the left to the right. If you're going backwards, you're actually needing to think of this as removing the area. So the way you want to treat this is you put a negative in front of the integral, and you're going to take these limits and switch their order. We really do want this to be left to right, but we are going to have a sign change here. Well, the area from -3 to -2 is -4, but there was this negative because I had my intervals listed backwards, and so I'll get a +4. Same issue happens here with number 11 in that this is written backwards. And so I could rewrite this integral as the negative integral from -3 to -1, so that these are going from the smallest number on the bottom to the largest number on the top. So we actually, I think, may have already done this one. -3 to -1, we actually did that in number 9, and we got a -1. We need to change the sign of that to +1. For these next problems, we are doing definite integrals. And so when you do definite integrals, you have to evaluate. We have to evaluate this. And so we would end up with x cubed, adding 1 to the power, and divide by that new power. So now that coefficient is 1, minus 2x squared when I divide by the new power. We do not write plus c because we're going to be evaluating this at 5 and at -2. So first I will evaluate this expression at 5, and then I will evaluate it at, -2. And I'm going to subtract the results. So if I substitute in a 5, and then I will substitute in to the expression a -2. And I need to simplify this. So this would be 125 minus 50 minus, let's see, this would be -8. If I do the power first, I would get 4 times -2 is another -8. So I would get 75 minus a -16 or +16, which is 91. Now, if I wanted to check this, I can check this on the calculator. Let's see if I can remember the expression. -2 to 5 of 3x squared minus 4x. Okay, so the integral from -2 to 5, let's see if I remember this right. 3x squared minus 4x. All right, 3x squared minus 4x. And then this is being taken with respect to an input variable of x. And we did it correctly. We got that 91. You do need to know how to do these by hand, by the way. All right. Number 13. Number 13, I will start by doing the integral, but with the power rule. So this will be x to the 5th. Dividing by that will make this 2/15 plus 3x. And I'm going to evaluate this at 1 and at -1. I evaluate it at the top one first. And then I subtract off and evaluate that at the bottom one. I would say that negatives cause a lot of problems. Sometimes kids perhaps do a little too much in their head and they make careless errors here. Well, we know 1 to the 5th is just 1 times 2/5 is 2/5 plus 3. And since I know I'm going to need to combine these, maybe I'll write 3 as 15/5 minus, this would be a negative 2/5 since I have an odd power there. There is a sign change. Minus 3, which is minus 15/5. So I'll end up with is 17/5. And then plus another 17/5, which is 34/5, which is not what I got earlier. Oh, this answer that I got earlier wasn't reduced. That is not either. What is that? Oh, that'd be 34. I don't know. Let's check it on the calculator and see. All right, from -1 to 1 of 2/3 x to the 4th plus 3. Let's see. All right, from -1 to 1 of 2/3 x to the 4th plus 3. Maybe I did it wrong earlier. And then don't forget the dx. So that is not the answer. What did I do wrong? Oh, I wrote it wrong. These are 15s. All right, so if this is 2/15, this would need to be 45/15. Now I feel a little bit better. Okay, so what would that be? I would then get 47/15 plus 47/15, which is 94/15, which I think actually does reduce. I think I can divide this by 3. Oh, no, I cannot. It does not reduce. Oh, I did do it right the first time. Way to go. All right, number 14. So the integral of cosine sine. So remember, it's backwards. So this is -2 sine of x, and the integral of sine is negative cosine. And I need to evaluate this at pi and at 0. So this would become -2 times the sine of pi minus the cosine of pi. I'm evaluating the whole expression at pi minus -2 sine of 0 minus cosine of 0. Well, sine of pi is 0, so this first part zeroes out. The cosine of pi is -1, watch your negatives, minus the sine of 0 is 0, and the cosine of 0 is 1. So I end up with +1 plus 1, which is 2, and that's a match for what I got earlier. Phew, glad. All right, that's the end of the solutions.